All right, so within the next few minutes, we'll be looking at basic graph with R. So the way we are going to do it is such that we are going to begin from something simple, then from there we can build up. All right. So we'll begin from something simple, then from there we can build up. I noticed that before now there have been some plots um, that we've tried to visualize, maybe in the course of theories, model fitting, and all of that. So, but some of the things we've been using, we don't even know, maybe in one way or the other, what they mean. Such that if you want to do your own plotting, you will be able to know that, okay, this is what I need to put here in order to have this result. So we'll be going through some of that under this particular course. So please let us not also um, okay, let me also make it clear that the what I'm using is different from what you will be using, although both of them are also on R. So what I'm using here is the R Markdown. I'm using R Markdown. It is like something you can use to create a notebook with R, where you have both the R code and some notes you can add, and also the house code. So that is what I'm using because I use that to prepare my notes. But for you, just use your normal house script that you have been using to type all the codes that you'll be seeing afterwards. Please, do we get that? So please don't be confused that what is this one? This one is somehow new. This is just the R Markdown. Okay, so let's get started. Basic plot. So the visualization of data through plotting is an integral part for the communication of modeling results, just like my colleague introduced to us that now you have gone through you've done all of the analysis of the data, you've gone through the model, now you want to present your results, let's say to the stakeholders, policymakers, or people who are interested in what it is that you are doing. So it is very important for you. Some of them don't even understand the maths, all this mathematical modeling, transition dynamics, all of those. They don't understand those equations. What they want to see is the output of all those equations that you have put together, and you want to explain your results. You want to explain the result of your mathematical modeling exercise. You want to explain this to them, so that we can do. We can categorize that under data visualization. So in this course, we shall look at basic plotting with R and also the use of ggplots, an important library for graphics. I've already knitted the working. HTML mondo, HTML mondo. I'm getting there. If I need to feed you, I'll be moving back and forth. People are complaining on the app. Let's put that this thing in. This media, can you help us see the screen? It is great. It is. In the mascot, I will be near. Okay. All right. Yeah. So we're trying to work on the font so that people could actually see. So I think it's okay now, right? All right. So can we continue? All right. People at the back, can we continue? All right. So we have, so the base R has the plot function. Please, let's take note of this. We have the base R. You will remember that sometimes, like under the time series, you imported some libraries. For instance, forecasts, right? And some other packages like that. So those ones are not on the base R. So they are external packages that you have to download, install, and bring into the base R. But the base R itself has some packages that when you open it, they open directly with it. So you don't need to import them. So one of them is this plot function. All right. So which can be used to render data in a visualized manner. The plot function does not necessarily need to be called as a library, like I have said. All right. So the plot function has some argument that can be used to control the appearance of the plots. We call them the graphical parameters. So we are going to look at these graphical parameters one after the other so that you can know what each of these parameters represent. Then you also be use them to modify your own plots as the case may be. So to start with, so let's look at this particular plot. It's just a simple one. So just like we have it in the code, let's just type it the way we have it in the code there. So we have x equals to sequence of 2 to 10, difference by 2, and we have the sequence of 1 to 5 as our for y. So we want to plot the graph of x comma y. And let us not forget, our plot also still follow the normal coordinates, which is the x-axis and the y-axis. So please, let's plot this and let's see what the result looks like. So you can see here now that here we are making use of the plot function. So you've been using plot. That plot is actually a function and it takes in several arguments. So part of the argument are the coordinates, then some other, what's that? Okay, sorry. All right. Please, I would like us to be fast with that. Please, let's ensure we are doing this. Very important. So, what's the output like? Have you seen anything? Do you like the outputs? It's not something you are going to like, but let's see how we can improve on that. Okay. All right, so I will continue. So some of this code we can snap it and just easily access it from our phone instead of looking up, looking down, looking up, looking down. So we can just snap it, just type it, then we can just run it from there. So this is what the output looks like. So from what you can see here, you can see that this does not really look so fine. It's not really communicating anything like that, apart from the fact that we have these points that just arrange themselves in a straight line, and it is also increasing. So you can't really say much about this, okay? So you can see that the plot looks so dry, but we can improve on it. We can improve the appearance of this plot with some argument associated with the plot function. So now every function has its own arguments. Please, let's take note of this. Please, are we together? Every function has its own arguments, and those arguments helps you to be able to modify or manipulate some things using that function. So now we want to look at some of the arguments that this plot function can actually take. The first one is type. Type. What do I call it? So what type tells us? Type tells us how to plot the supplied coordinates. For instance, now if you look at the one you have, it is just point, isn't it? Now we can make it straight line. Are you getting it now? We are saying that let the plot point be line type, and then we have other values that that type can also take. So type now is an argument that takes several values. So I'm going to show us now. So the possible types are P for points. Are we there now? We have type. We have we've just finished plotting. We have plots x, y, isn't it? Then the other time we close it. But now we want to improve this plot. Are you getting it now? Maybe we don't want it just to be just points. So we can say that, okay, let the plot point type be, for instance, now we have used points. Are you getting it now? But it can take other values. We can say line. If you change this to, now you can see that before now it just brought out point, but now we are bringing in type to modify the output. Are you seeing that now? So you can also use B, which is for both. We can use C. So we are going to see the other values that we can also use. But let's note that whenever we want to put in the values are usually in quotes. Are you getting it now? So please, let's take note of that. It is in quotes. So if you are to look at this now, back to the slide, please. So we have possible types are P for point, L for lines, B for both lines and points, C for the lines part alone of B, O for both overplotted, H for histogram like vertical lines, S for tiered steps, and capital S for other steps. Now, let's go back to the plot function. We already have this. The only thing is that we have not included type, isn't it? So let's change that type to O. Let's change it to, I would like us to try each of these values. So try O, plot it, see the result. Type L, see the result. Type H, see the result, so that you can see the differences. I'm going to give us about 1 minute to do that. Just change those type values, but ensure they are in quotes to avoid mistakes or errors. O should give us something. Not 0. O, letter O. Letter O, not 0. So change it again to letter C. It's all small letters apart from the last one, which is capital S. You will see the difference. You will see the different types of plot points that it will give to you. So can try H, try small s, try capital S, try C. So I think we have seen varieties of the plot points, isn't it? Right? If you have done like 2, can I see your hands up? You've done like 2 and you have seen the differences. You have done like 2. All right, thank you. So I think now, when you see type, you know what it represents now, isn't it? So let's continue. Let's continue. So now, this is my home here. Then we have main, xlab, and ylab. Main to give you the main title, xlab to give you label for the x-axis, ylab to give you label for the y-axis. Please, do you understand that now? We have main to give you the main title, xlab for labeling of the x-axis, ylab for labeling of the y-axis. You know, our Cartesian coordinate looks like this. So we have the y-axis, we have the x-axis. Now you want to label it. For instance, now we are currently working on our project, and possibly you have data that you are working with. So you want us to even see the data to see how it looks like and all of that. Then maybe the data is in incident, monthly incident data. For instance, you say, okay, let my y-axis rather be time, which is in months. Are you getting it now? If you are looking at, let's say, malaria cases, you say this one here represents malaria cases. Are we there? So now, how do you do this labeling yourself? You can do that, and maybe this one you are trying to say that the main title now is, you are saying maybe malaria cases in Borno, maybe 2014 to 2020 as the main title. Are you getting it now? So you want to put this all by yourself because you have something you want to represent to show to us. So you can do that making use of the main, xlab, and ylab. Please, are we together? Are we together? All right, so now let's see this. So you can see now that little by little we are improving our plot, isn't it? We started with just dots. Now you've known the various types values that you can use to modify the plot points, but now we want to now label it. So can we go on and do that? Main, plot of y versus x, xlab, x-axis, ylab, y-axis. Xlab means x label, ylab means y label. Are we done with that? And don't forget that the entries also are in quotes. Reason be that what you are typing, they are characters, and in R you type characters or strings in quotes. All right? Very important. Giving us 1 minute to do that. Okay, so I think we can move away from there now. People at the back, are we together? Okay. See, we can always snap this thing, put the phone, and just type from there. Okay. Okay, so the next thing we want to look at is, so this is my home results. We want to look at color or colors to use for plotting points and lines. So maybe the default color is just black when you plot normally. But you know, sometimes maybe because you are looking at malaria cases, measles cases, HIV cases, you know, sometimes you want to use a color that depicts the fact that what we are dealing with is serious. And sometimes you want to use red for malaria cases, HIV cases, you know, because you are talking with public health officials and you also want to relate with them. You know, color color speaks a lot. Color speaks a lot. So you want to change the color. So you can do that using this call argument, COL, call arguments. And this is just it here. So you say call equals to, then you type the particular color you want. Right. You can change yours to blue. I think there's something I want to talk about. All right. So just you can change the colors to. I want to check something. I don't know if I still remember. All right, so okay, so let's move it from there. So you can see I've changed mine to red, so I'm having red. So then we have PCH. PCH means point characters. What does it mean? What do we mean by saying point characters? So take for instance the other time when we plotted the values we have, you could see just points going upward, just points, right? So this point represents each of the point of the graph. So now you may decide that I don't want mine to be this point like this. I want it to be dotted. It'll be something like dot like this, dot like this, something like this, something like that. Okay, and sometimes you may want yours to be star. Are you getting it now? You may want it to be star. Okay, and different characters like that. That's how we call it point characters. So it actually takes value from, I think, 1 to 25. It takes value from maybe 0 to 25 or 1 to 0 to 25. It takes value from 0 to 25. So like for instance, now we have set color red. So you can see the PCH I used 19. This 19 here will correspond to a particular point character. Are you getting it now? So unlike other arguments that have been taking values in quotes, this one take integers beginning from 0 to 25. So what I will want you to do now is include this point character, okay, and then try to vary this value that it can take and see the different characters that it can output. Please, do we get what I said? No, I said it can take value from 0 to 25, isn't it? You can even try 0, plot it, see what comes out. 1, plot it, see what comes out. Maybe like 4 to 5 different values and see what comes out. Then we have this sex, which is okay. We are going to look at what that also represents. How about now? You said nothing happened. I'm coming on. Okay. Hold on. Nothing happened, right? Now pay attention. Do you still have type? Remove the type. Remove the type. Type P. Okay. Then we can now change the values. We should have a change now if you remove that type. Right? All right. It is because the type overwrites whatever is there. Are you getting it? It is precedence over those ones. That's why it is just like that. Okay, let's look at the CX argument, which is the character expansion. This controls the size of plotted point characters. It takes both integer and float values. Are we together? Now, to to see that effect, let our point character be 19. Please change it to 19 so that we can see that effect. Please change it to 19. I don't know what your home value is currently, but just change it to 19. That will be able to see the effect of this character expansion. Are we there? Okay, now let's change this to 1. You know, here it is 2.5, right? Change this to 1 and plot. Change it to 1 and plot. Then thereafter, change this to 3.0 and plot. Do we see the difference? So you can see that it is for the points. Are you getting it now? So you use this to increase the size or to control the size of the plot points. Please, are we seeing that now? So you will see some of the plots that you've had before now. So if you go back to look at it now, you will know what each of some of those things actually represent, right? All right. So and yes, let me quickly submit this at this point. Please, let's pay attention. Let me quickly submit this at this point, please. One thing about R is that you cannot always have the codes in your brain. All right. So please don't try to cram codes. Rather, learn how to use the syntax. Are you getting it now? Let me give you an instance. Let's say, for instance, now, I'm just learning English language. And for everything I'm hearing from people, I'm trying to cram it. Maybe this person said, I saw you going to the market yesterday. So I crammed it. I saw you go to the market yesterday. When we now enter the class, the English teacher said, the past tense of go is went. I said, okay, went. It's all right. Now, I've been cramming. I don't understand syntax. I don't understand. Please remind me this thing. Is the figure of speech, right? Part of speech, isn't it? I don't understand all those things. I've crammed. So now I saw you. I'm confused. The teacher said the past tense of go is went. And it was yesterday I saw you. Now I want to tell you, say, I saw you went into the market yesterday. So are we getting it now? So that is the way it will be if you are trying to cram our codes. Are you getting it now? What is most important is know how to use the function, know the syntax. Are you getting it now? There are some that because of your daily programming, you use R by and by, now and then. They are just at your fingertips. Are you getting it now? But there are some I have to be humble enough to tell you that you may need the help of AI or Google and some other websites to get what you need. But one thing is that if you understand the syntax and also the flow of codes, when you even see something new that you have never seen before, you can read and understand and apply to your work. Sometimes what you're even looking out for, maybe online, you may not see the exact one that solves your problem, but you may see something similar that by reasoning, because you know the syntax, by reasoning, you'll be like, oh, if I do it this way, I should be able to get what I actually need. So that is what I will advise you to do. Please, are we together? All right. For instance, now, when I started out learning programming, I started with HTML. I can tell you now, if I'm standing in front of you, if you tell me that, okay, just come and write a simple stuff in HTML, I only know that there is one exclamation mark, doc type, close it, and then the head, something like that. The other things are forgotten. But because I have done it before, I understand the flow, the syntax. It's just a matter of me seeing sample codes. When I'm able to read, I'll be able to follow again because I learned the syntax. Please, do you get what I'm saying now? Please let it also be for our R. Very important. You don't cram codes. Rather, you try to understand the flow. Is that one taken? All right. So now, the next thing we want to look at, so we have been able to see that, then LTY. LTY stands for line type. It stands for what? Now you have plotted the line, but you don't want it just to be a straight line. Sometimes you want broken line, dashed lines. Are you getting it now? So with the aid of this LTY, which is line type, it takes value from 1 to 6. You can have different line type. Please, are we together? So I don't know if I use it here, but maybe we should just try to do that. So now, in your code now, you can now put comma, from the last argument you have entered, just put comma LTY equals to 2. See what the line will look like. Change it to 3. See what the line will look like. Change it to 4, 5, and 6, and see what the line also will look like. Line type LTY. You can put it anywhere. You can put it anywhere. There's no code for that. I didn't include it here. So I didn't include it here. I don't know. It's like I didn't include that here. Yeah, I think. So after this character expansion, just put comma and then put line type equals to, you may start with 6 to see what it look like. Change it to 3, run it to see what it look like. Change it to 1, run it, see what it look like. Change it to 2, run it and see what it look like. Right? Eh? You said? Okay, it's not okay. Return back to type. Yes, return the type. Type equals to L. You know it is line type now. Line. So your type value should be L, which is line, not O. Do you get what I'm saying now? All right. It should be L because we want to see line type. So your type should be L, which is line. All right. So and that means in that sense also, okay. So let's see that. So what we are saying is that put your type back and put, this is not, this what you'll be seeing will be different because this is Microsoft Word, not our script. So we're not saying that do something like this and put 2, then vary it to see the differences. Are we done with that? How many of us have been able to do something with that? How many of us? Very few. Or we're not getting it? Man, you can leave it. You can leave it. Please, if you have gotten it, help those around you, please. Help those around you if you have gotten it. Eh? Okay, maybe let me go to my own here. Where are we now? I think so see it now. If I change this to 5 and I run it, I'm going to have something different. I can view it here. I'm going to have something different. So you can see this one is dash line to be different from if I change it to 3 now. If I change it to 3, it's another thing entirely, right? So that's it. So that's it. Okay, can we continue? Any question about that? All right, so let's continue. All right, please, are we getting it? Our yes is too low. It means only few of us are getting it. Are we getting it? All right, I like that. So now the next thing we want to look at is, so you will see now that while we're changing the line type, it was difficult to see the difference. It's because the whole line is very thin. So we were unable to really see the difference. So we can see the difference now by increasing the width of the line. And we do that by using LWD, meaning line width. All right. So now let's include line width, LWD, and put it as, let's say, 2. Put 50. Let us see what it looks like. So are we there now? So include this line width, put 2. Plot it and see. Now change those values again now. The values of the line type. Change it and see if you'll be able to now notice any significant difference. Right? So you can see because you have increased the line width, isn't it? Wait, have we seen that now? So as we are working on our project, please let's pay attention. As we are working on our project, these are the things we need to look at. Okay, how do I apply it? Please, are we together now? How do I apply it? So that's why we have been taking through all of these things, applying it. All right, so the next thing we have here is the S-limb and Y-limb. Well, I don't know how to explain this better, but we'll see a practical example where this will be needed. Is that one taken out? But just for now, he said these provide limits for the horizontal range and vertical range, respectively, of the plotting region. Okay, now the S-limb, or let me use the Y-limb. The Y-limb is just talking about the maybe you want the plot area not to go beyond a particular value. Are you getting it now? Let's say this guy here now is going up to, let's say, 1 million. But you don't want it to reach up to 1 million. You just want it to be from 0 to 800,000. Maybe, you know, this thing also, when you are plotting, it has its own default way of setting the graph. Are you getting it now? But now you want to control what the value on the y-axis should be, the range. So you can say the y limit, it's like saying y limit, y-axis limit is equals to C0 to, let's say, 800,000. So when you set this, it won't go beyond, it will be between 0 and 800,000. You will no longer see 1 million. Are you getting it now? We usually use this, we are going to see the case. Maybe when we get there, you will see it better. I want you to really see it. Then when I'm now talking, you will understand it better. Now, how can we add? Yes. So now, the question we have before us now is this, that how can we add more plots to an existing plot? Are you getting it now? And because we want to add maybe more plots to existing plots, that is actually what necessitates the need for maybe changing, knowing line types. If those plots are going to be lines, for instance now, if you have 2 lines, right? Maybe one is going like this, all right? Okay, no. Let me see one. Let me use just 2 straight lines. One is going like this, the other one is going like this. For instance, these are 2 lines. Are you getting it now? So now, you know, when you are submitting a work for publication, sometimes you want to separate between these 2 lines to say this one mean this one mean this. So sometimes you don't want the line type to be the same, as the case may be. Sometimes you just want this one to be maybe dashed lines. Are you getting it now? You want this to be dashed lines, and this one possibly you want to leave it this way. So that, let's say for instance now, somebody print this out as black and white. Even if the person does not know that, oh, this is what this one represents, this one represents. Mere thing, the person knows that these 2 things are different things. Are you getting it now? The person can go to the caption to know what each of them actually represent, than you saying You know, you did not label this one as A, this one as B. So if I'm saying the first line represents this, the second line represents this, the person is confused. Which one is which? But if you say dashed line, then the other tick line, you can say the dashed line represents, let's say, interaction. The tick line represents transition. Somebody is able to see that. Why? Because the line types are different. Are you getting it now? These are cases where using line types are very important. So now, how can we add more plots to an existing plot? Let's see the way that can be done. Calling the plot function several times override the existing one. Okay? Maybe for instance now, you know, we've been plotting something before now, isn't it? So it is now that you want to have another plot, but you want it such that it should be on this one you've been using before. But now, when you wanted to do that, you call the plot function. Are you getting it now? If you use the plot function, what happens is that the one that was there will be overwritten. Are you getting it now? What will be output now will be the new one, the new function you are working with. Whereas you want both of them to be on the same plot area, right? So let's see how we can do that. So we have, with the functions below, other plots can be added to the existing one. The following function, we have points, lines, hub line, which is AB line, segments, text, arrows, legends. We may not be able to look at all of these, all right? But we'll look at 1, 2, or 3 of them, as the case may be, based on what I've put together here. So let's say, suppose that there is a function to be plotted on the same canvas, say y equals to all of these, for x equals to 2 to 10, with difference of 2. Are we there? So now what I want us to do now is this. I want us to type this. We want to plot this function now on the same plot area. So let us just put out this. X1 equals to this, x2 equals to this, and let us plot this one. So we have 0.92x squared plus 0.877x minus 0.994. We want to plot that and see the way it looks like. We have 2 minutes to do that. I hope we can see it. Let me scroll it up a little. I think these are just basic operations in mathematics. This asterisk means times. The cap here represents raised to power. Please, are we there? So very, very important for us. So I think we have been taking through this one. So that's just the way it is. If you just write 0.92x, R does not understand that. So you have to put your asterisk to say that this constant or this coefficient is actually multiplying whatever it is that is here. Okay. Let's continue. Since we have declared x before, actually this one here should be x1 because we have said x1 here, isn't it? But it is still going to run. Do you know why? Who can tell me why? Because you have x earlier, and that x, the x has the same value as this one, isn't it? So whether you change it to x1 or you leave it like that, it will still run. Do you get what I'm saying now? All right. But in case you need a different value entirely, please, you need to change this. We are leaving it here because both x1 and x, they have the same value. Please, do we get that? Okay, so that's why we are leaving them. In the real sense, this should be x1 and x1 here. So do we have our plot now? All right, so you will see that now. I want us to see something, please. Very important. If you look at the range of y here, you will see that it's going from 0 to like 100, isn't it? Now, but the previous one we had, let's look at it now. That one ranged from 1 to where? To 5. So now let's see something. I want us to see something. This is 1 to 5. This is 0 to 100, isn't it? Now, let's now assume that the previous one, I want to put it on this. Where do you think that line will appear? Eh? Where do you think it will be? It will be down, 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 isn't it? Because the highest value there is not even up to 20, which is the first as is here, isn't it? So now, so the issue is, so how can we manage this? Are you getting it now? So let's see how we can manage it. Let's see how we can manage it. All right, sorry. Okay, we have plotted this one, Abi. Okay, I think I have an exercise for us. So the exercise is this. So this one that we have just plotted, please, are we together? This one of y1, x1 that we have just plotted, I just want us to practice something little. Change the axis labels to temperature and development rate for the x and y axis respectively. Do you understand what I mean by that? This one you just plotted now. I just want us to practice what we have learned so far. So change the axis labels. The x-axis to temperature, the y-axis to development rate. And let the main title be plot of development rate. Change the plot from points to a line. Change the line color from black to blue. The new plot is just generated now. I want you to perform this task on them. And development rate, I have them in bold color already. I think we can see it now. You said? I said let the main title be plot of development rate. So you can see plot of development rate. Then change the plot from point to a line. Change it from points to a line. Then the line color now, change it from black to blue. First person to finish will be given handshake. You know, Mr. ID gave you kudos. Are we done with that? What's your x-axis now? What's the x-axis now? The y? What's the main title? Not the one on the screen, no, the one on your screen. Do you have point or point character? Okay. Do you have red or white? Somebody say red though. All right. Okay, so now let's continue. That one is just for us to practice one or two things that we have learned. So now let's plot the two functions together. You know, we have said we want to put the two functions together now, isn't it? On the same plot area. So then we'll see where the y-lim is applicable. So now we already have this, we have this, right? Right? So this is the y-lim here. Please, let's pay attention to this. This is the y-lim here. We are saying that let our y-limit be from 0 to 100. Are we getting that now? Then, because the next one, the other function we want to put now is also line. So we are now saying that instead of writing plots, are you getting it now? we want to plot the second one now. You know, that one is our y1 here, isn't it? This x that we are seeing here is common to both of them. Now, this is a function. This is another one. These are y values, another y values. And want to plot these two on the same plot area. This is the common x values to both of them. So now, the first one we are seeing here is for this first one here. Please, are we there? Are we there? Okay. Can I continue now? All right. People at the front, can I continue now? All right. I'm referring to those at the back. But we are at the front. Amen? All right. So, now, you see, let me just say something. You see this one here now? The highlighted one. It's just like what we have been plotting earlier. Are you getting it now? Now, the second one, which has to do with y1. Are we there? I want to add this to that one. To be on the same plot area. So, you know, that means I also want to plot it, isn't it? Okay. Now, let's check out something. Please type this out. Are we there? We already have this. You can just copy and paste. So, and only add ylab. Instead of lines that we are seeing here, right? Please put plot again. Don't let us use lines. Put plot. Yeah, put plots. I want us to see what I'm talking about. Instead of lines, put plots. Are we there? Now go to the first one, run it. The second one, run it. Don't put lines yet. Put plots here also. Put plot. The first one plots. The second one also plots. Are we there? This one, instead of lines, put plots. Like put plots and run it. Run the first, run the second. Are we there? Are they on the same plot area? Are they on the same plot area? No. So now what that lines is going to help us to do is to put both of them on the same plot area. Are we getting it now? So it is like that lines is also serving like a plot function, but adding it to an existing one. Please, do we get that now? So if I say lines, all right, we will go back and plot the first one and this line now and see what will happen. What do you have? You should have something that looks like this, right? So you can see we have plotted both of them now on the same line. I mean, on the same plot area. And it is not limited to lines alone. You can also use points. Please also try points. Remove this type. Also try points. So run the first and the second and see what's going to be like. We have tried lines, and I say it is not limited to lines alone. Also type points and see what's going to be like also. Sometimes you need points instead of the lines. So for this one now, you can even change this one now. You can say this one is, let's say, okay, let me just leave it this way. So use points. So what do you see? Lines and points. You see the line up there, then the points below. Please, are we together? Are we together? We have I think we still have 2 hours left, right? Can we continue? Change that lines to points, then plot the 2 again and see what happens. Which line? It's not showing. Did you use ylib? 0 and 100. 0, 100. Those of us that have done it, please let's assist those who are still making breakthrough with it. If you have done it, please assist those who are about to break through with it. So the result looks like this. Are we together? Yeah? The code again. Please, let's snap it now. Before the point, what was there before was lines. Yes, x comma y. X comma y1. Right? I think before it was like this before. It was like this before. Right? Please don't forget, this is not our script, so it won't look like this. It won't look like this on your own our script. So please let us not forget, this is not our script. Okay. Can I continue? No. Line, point. I think we can move on now. I only need a yes. I think we can move on now. I only need one yes. I think we can move on now. I only need one yes, and I've gotten the yes. All right, so it's not limited to lines alone. You can also use points as described below. I've shown you this one. Are we there? I've just shown you this one. We can use points. And because we are using points, you can use the point character. You can change it to color. You can say let the type be blue. Let the type be B, as you can see in this case. Are we seeing that? So we can change that lines to points, add point character, change the color to blue, change the type to both, meaning both line and points. Are we there now? We can so that we can have a result that looks like this. Are we there? Code Abby. It's just to modify. You already have all of these. So it's just to modify this one here. Just more. Please, are we getting the flow? It's not just about just typing the code. Understanding really matters. No, just like I told us, understanding the syntax is very, very important. Very, very important. Understanding the syntax, understanding the flow, understanding the usage. Those are very important. So do you have this? You can snap and to hasten it up. We can move on, right? So do we have this output? Do we have this output? All right. Okay, so now, so let's take, for instance, these two represent different function. Now we want to add a legend. Please, let's take note of that. We want to add a legend. So we say a legend is a graphical element that provides a key to interpret the symbols, colors, or patterns used in a plot. Are we there? We want to add the legend to be able to distinguish between this one and this one. Are we getting it now? Maybe for instance, now maybe this one is mosquito biting rate. This one is parasite development rate. Are you getting it now? So you want to be able to distinguish both of them using a legend. So how can we add the legend? So please let's hear this. We are almost done, at least for today, on this one. So we say a legend is a graphical element that provides a key. So this is what we need, a key, to interpret the symbols, colors, or patterns used in a plot. So let's add a legend to our plot now. So we already have all of these ones. We already have this. We have this. All right. Okay. AB line. Okay. Let's see this AB line. Let's see this AB line maybe before the legend. Are we there? Let's see what this AB line does. All right. I would like you to see it. I would like you to see it. Now, let us add this AB line under our point. AB line, H means horizontal, V means vertical. We already know what this one means. Line type, line width. All right, let us add this AB line, then run the 3, 1, 2, 3 with the AB line. All right, then we'll see what that actually represents. AB line is can either be, so let's just type that one first. So the AB line. So sometimes maybe while you are doing while you are carrying out a modeling work, one of the things you want to do is to predict. Are you getting it now? The data you have, maybe you are working with a data, for instance, let's say the data is from 2015 to 2020. Are you getting it now? And you have used your model to capture what is going on from 2015 to 2020. Now, with the aid of your model, you want to predict what the disease cases may be for the next 5 years, maybe up to 2025, let us say. All right. And because both of them are on the same plot area, you want to distinguish between what you have done with your model fitting from what you are now predicting. Are you getting it now? You want to have a kind of demarcation that anybody reading with, when the person sees that demarcation, the person is able to know that, okay, it's like something is going on here. There is something before, there is something after. You want to do something that looks like this. Maybe you've already had whatever, and this is from, you have to, let me say 2020, you have something like this. This is what your model, you are able to fit with your model. But now you want to predict from 2021 to 2025. So you have something like this, for instance. Are we there? So you have a line, all right, this vertical line, saying that, okay, from here to here is my model fitting. Are you getting it now? What I'm having after here is the prediction. Are you getting it now? So how do you add this line? That is where AB line comes in. Now, this one here is vertical, so you use V. Had it been what you want to add, for instance, maybe you have a threshold that you are trying to depict on the y-axis, a threshold that looks like, let's say, something like this, for instance, that, okay, oh, this is the threshold, like nothing goes beyond here. Maybe anything coming here eventually just become like this, or anything coming from up like this eventually just straighten up here. So this now become a threshold, which is a vertical line. Are you getting it now? So you want to put that vertical line on your plot area. So the AB line can still do that. So this vertical line now, that is where you use V. I mean, this horizontal line rather, that is where you use H. This vertical, that is where you make use of V. Please, do we get that now? All right, so let's look at, let's go back to what we have now. So if you see your own AB line, you will see we have H equals to 15 and V equals to what? Equals to 4. Then what follows is the line type. We are saying that let the line type of the first one be 3. Let the line type of the second be 6. Are we there now? Because we have two things declared here, the horizontal and the vertical. So we are saying let the line type of the first one be 3. Let that of the second be 6. And then let their line width, the line width for both of them be what? Be 3. Are we there? We have declared that let our horizontal line, let the AB line be H equals to 15 at the horizontal side. For the vertical, let it be at the point V equals to 4. This is the vertical. This vertical now we take from the x-axis. The horizontal we take from the y-axis. Are we there now? Now, because we have two of them, and we want the line types to be different. So we said the line type is the first one, let it be for 3. The second one, let it be 6. But let their line width be the same, which is just 3. So if you run this, and this AB line, you will see what we mean. On your plot area now, you should have these two lines. Are you getting it now? You should have two lines. Please, are we there? Do you have the two lines? I don't know if I have it here. I don't have it here, but I think I just put it there so that people can carry it out. The code is here. Are we there? I thought we have finished this. Come, where are we? AB line. So have we tried to see the output? Do you have two lines? One vertical, one horizontal. Okay. Do you understand that AB line? Now let's go back. Let's now go to legend. The AB line. You want to put a line whose value on the y-axis is 15. So you have H equals to 15. So it's going to come here. You know we have 0 to 100 here. So at the point 15, that should be before the 20. You will have a line. Are you getting it now? Then for the vertical, which is V, you have V equals to 4. You know, here we have, I think, 0 to 5, something like that. Right? So is it 0 to 5 or 0 to 10 now? So 2 to 10. So 2 to 10. So on this one here now, at the point 4, there will be another line. Are you getting it now? So that is what that represents. Okay, I thought we still have 2 hours left. Okay, I was just told now that, okay, the time is up, or I should spend a few minutes more. Okay, so let me just stop at this legend. I think that's where I also want to stop for today. Yes, that's where I want to stop for today. So we have, I've not finished. Okay, so for the legend, so we have the top left, at least from the code, you can see the top left. The top left is just to tell us the position where you want the legends to be, and it takes several values too. So we have, apart from the top left, we have bottom right, bottom left, top left, top right, right, and center. So these are the values that it can take. Just tell us the position where this is the legend here, where the legend can be. So here is the code, and at this junction, I will want to say thank you for working with me.